A new frontier of renewable energy is crossing Iceland. In the land of fire, the homeland of geothermal energy, they are testing a technique to drill wells 5 kilometers deep to bring steam to the surface, at temperatures of up to 500 degrees centigrade. If all goes well, the amount of electricity produced by these sources will increase tenfold. Hot liquid and steam stored inside the earth have a huge potential to generate electricity, such as through turbines. Here in the Reykjanes peninsula, they're drilling beyond the usual 2.5-kilometer depth of a geothermal well. Technicians have reached what they call supercritical steam, a huge source of power reaching 500 degrees centigrade, close to magma's reservoirs.
We need to drill deeper and help nature a little bit to get the heat out of the ground. If we find a fluid at this temperature, it will be what we call supercritical conditions. And if we can drive that gas up to the surface through the drill hole into a power plant, in this case we are expecting 30, 40, 50 megawatts.
That is the goal for DEEPEG's Deep Enhanced Geothermal System. It aims to increase the use of geothermal systems in Europe.
So experience gained in Iceland can be used in Italy and vice versa. And the same for experience in Japan or New Zealand. So we can use the same technique. So it's a learning process. We like to learn from each other.
One of the main challenges for the DEEPEG's team is finding out what the rocks are made of, while testing the new deep drilling techniques. Being aware of the composition of the soil is key to avoiding structural damage or security issues.
Drilling into the unknown is a big challenge. Today we have no means to see exactly what we are drilling through. The problems we are facing is the chemistry of the fluid. We have to deal with scaling, corrosion and other things.
Drilling the Earth's crust is a risky operation, also because the drill can go through magma reservoirs or small earthquakes could be generated, especially in volcanic areas.
We try to minimize the risk while we are with geophysical measurements, volcanological history mapping and so on, with all sorts of science tools before we drill.
Bringing up steam from the hot heart of the planet also means getting harmful products such as CO2 and sulfur. The Icelandic approach is to recycle everything.
If we look at a power plant as a box, we are to look at every resource stream coming into the box, like power, hot water, groundwater, just name it. Look at it as a valuable stream, not to be wasted.
Final results on this technique will be ready by the end of next year. If this technology can produce more power than conventional geothermal wells, fewer wells will be needed to produce the same amount of energy, and the environmental impact would be lower.